previous video, we spoke about the ball being thrown diagonally. Let's think about how we can draw this schematically. First of all, I suggest we start with the ground. Here is the ground. And here is the ball in the starting point. And the ball is being thrown this way, diagonally. So it has a component of velocity going this way, and it has a component of velocity going this way. And if you can remember from the previous video, we said that these two are independent from each other. And actually these are vectors. This is a vector, and we just disintegrated this vector to its components. We chose our axes to be x in this direction and y in this direction. But this is a bit technical, and we don't have to go into it right now. What's important is that we threw the ball up at a velocity of 10 meters per second. So according to previous videos, we know that it will hit the ground again after 2 seconds. So now we can draw some kind of trajectory, and we understand that if the horizontal velocity was 10 meters per second, what would the distance be until it hit the ground again? The answer is 20 meters. And if the initial horizontal velocity was 30 meters per second, the distance would be 60 meters. In other words, the initial horizontal velocity remains constant and is also the final horizontal velocity, only that when the ball hits the ground again, it gets stuck there and can't move anymore. But this is a diagonal movement under the influence of gravity, near the surface of the Earth, under the standard acceleration of 10 meters per second per second. And you can describe this problem in many ways. You can think about a ball being dropped out of a moving vehicle like a train, a bus, or an airplane. But it's all basically the same. That the main principle is that the vertical and horizontal velocities remain the same. Possibly in a later video we'll talk about what's the ideal angle so that this distance will be maximal, assuming that our initial total velocity, this velocity, which can be found according to Pythagoras' theorem from our vertical and horizontal velocities. So which angle do I need to get the maximum distance? We'll do that in a later video. But for now, here is the diagram. Diagonal throwing of a ball.